Hello everyone, welcome back to our YouTube channel. In this video we are going to see about the pass transistors when an NMOS or PMOS is used alone as an imperfect switch. We call it as the pass transistor. Here we can see the NMOS pass transistor and PMOS pass transistor in two different configuration, that is when when source is grounded and one more is when source is connected to VDD. We see that the NMOS pass transistor is used to pass strong 0, and one more when it source is to VDD and drain to the output, it is weak 1. The output will be VDD minus V threshold of that NMOS. And similarly in the PMOS pass transistor, we can see that the two configuration when to pass strong 1 and weak 0, that is output Y will be V threshold of the PMOS. Next is the transmission gate. By combining an NMOS and PMOS transistor in parallel, we obtain a switch that turns on only when 1 is applied to the gate of NMOS and 0 is applied to the gate of PMOS. We call such structure as the transmission gate or T gate, or also called as the pass gate. You can see the structure here. PMOS and NMOS are connected in parallel, and here you can see the various symbols, the various representation, how we can represent the transmission gate. The output follows the input, that is Y is equal to X only if A is 1 and it is unknown for the value A is equal to 0. CMOS design with the TG, that is the transmission gate. Multiplexers are the key components in the CMOS memory elements and the data manipulation structures. A multiplexer chooses the output from among several input based on the select lines. For a 2 input, that is a 2:1 MUX or multiplexer, which chooses D0 when the input the select line is 0 and input D1 when the select line is 1. The Boolean expression is shown here, that is Y is equal to S bar dot D0 plus S dot D1, that is S represents the select line here and the MUX structure is shown here. You can realize 2:1 MUX using the transmission gate as shown here, that is using D0 and D1 as the input given to the two different TGs, and the select lines as shown here, that is when the select line S is equal to 0, that is it is low, then TG1 will be on and TG2 will be off, and the output Y will be same as the D0, that is the input of TG1. And when S select line is 1, the TG1 will be off and TG2 will be on, and the value of Y, that is output, will be same as the input for the TG2, that is D1. This is how we can realize 2:1 MUX using TG. We can also realize 4:1 MUX in the similar way. You can try it. And for more such videos, kindly subscribe to our channel, and thank you for watching.